space of a vector space V over the field Z3 and operations are additive modulo 3 and multiplicative modulo 3 such that dimension of V is 7 and dimension of W is 4. Then the number of elements in V over W means subspace W of V. As given in this question, the dimension of V is 7, dimension of V is 7 and dimension of W is 4. Now what is the role of giving dimension of these two spaces? As you want to find, or I am want to find dimension of V over W means dimension of quotient space W of V, and this is equal to dimension of V minus dimension of W. This is the theorem, and this theorem is only true for finite dimensional space. So if V or W or any one of them is in finite dimensional space, then we cannot find this relation, or we cannot apply this concept. So dimension of V is 7 and dimension of W is 4. So we obtain 3 as the dimension of this quotient space. Now what is the role of this dimension? To find the number of elements in quotient space. As field is 3, Z3, and we know that elements are 0, 1 and 2. As a dimension of the subspace is the number of independent linearly independent vectors. So there are 3 linearly independent vectors. If we multiply these vector from a constant which are coming from Z3 means suppose C is coming from Z3, so C V1, C V2 and C V3 will be another new elements in the quotient space. So role of the dimension in this problem is this. So number of elements in quotient space V over W is equal to dimension number of elements or cardinality of F raised to the power dimension of V, and dimension of V is, so cardinality of F is 3, so 3 raised to the power 3 means dimension of V over W. So answer is 27, because of if we choose any element C equal to 0 from Z3, and we have 3 independent vectors V1, V2, V3, so 0 times V1, 0 times V2, 0 times V3, it will be new 3 elements. Similarly, if we choose C equal to 1, then again there will be 3 new elements, and if I choose C equal to 2, then other will be 3 elements. So we have 3 independent element for different elements. So 3 into 3 into 3 means 27 are new elements in this. So according to this, option D